Normalization. Database normalization is the process of organizing the fields and tables of a relational database to minimize redundancy and dependency. Normalization usually involves dividing large tables into smaller and less redundant tables and defining relationships between them. The object is to isolate data so that additions, deletions, and modifications of a field can be made in just one table and then propagated through the rest of the database using the defined relationships. There are three different forms to database normalization. First normal form, second normal form, and third normal form. The first normal form, as you can see, we have a unnormalized table at the top. Tables, for first normal form, tables should have only two dimensions. Since one student has several classes, these classes should be listed in a separate table. Fields class 1, class 2, and class 3. In the above records are indications of design trouble. Spreadsheets often use the third dimension, but tables should not. Another way to look at this problem is with a one-to-many relationship. Do not put the one side and the many side in the same table. Instead, create another table in the first normal form by eliminating the repeating group class number as shown just below. In our second form, note the multiple class number values for each student number value in the above table. Class number is not functionally dependent on student number, so this relationship is not in second normal form. It is still in the first form. The following two tables demonstrate second normal form. The third form, in the last example, the advisor's office number is functionally dependent on the advisor attribute. The solution is to move that attribute from the student's table to the faculty table, as shown to the right. Some of the pros of database normalization: searching, sorting, and creating indexes is faster since tables are narrower and more rows fit on a data page. You usually have more tables. You can have more clustered indexes, one per table, so you get more flexibility in tuning queries. Index searching is often faster since indexes tend to be narrower and shorter. More tables allow better use of segments to control physical placement of data, and there are a few more listed here in this example. The cons of database normalization: that it's difficult and expensive to do well with, requires skill to provide functional views and access methods that are comprehensible and streamlined for consumer OLTP applications, requires discipline to maintain conceptually current and normalized, requires skill and discipline to keep well indexed, and last, requires skill and experience to create and manage OLAP view and the ETL process that populate it. In closing, as with many formal rules, the specifications, real-world scenarios do not always allow for perfect compliance. In general, normalization requires additional tables, and some consumers find this cumbersome. If you decide to violate one of the first three rules of normalization, Make sure that your application anticipates any problems that could occur, such as redundant data, inconsistent dependencies. Thank you.